Now, in this lecture, I am going to discuss a problem. The problem in this lecture, which I am describing, is that orbital angular momentum operator commute with the potential energy for central force. So, let me first of all decide the potential energy operator. Potential energy operator is basically alpha upon x if it is a one-dimensional problem, and this is the potential energy operator. It's like alpha upon x. So it is the operator for the potential energy because of the central force. Now, let me consider orbital angular momentum, and let me try to find out its commutated with alpha upon x. So it is Lx alpha upon x minus alpha upon x Lx, right? So that is our purpose, and it must be equal to 0. So to solve this, let us proceed as follows. As I know that this Lx is equal to minus iota h cross by curly over curly z alpha over x minus alpha over x, and Lx will be minus iota h cross. This is y curly over curly z, right? So that's what I'm interested to find out. And let us operate it with the psi x. If I operate it with the psi x, then I can write on it as, means this part can be rewritten as iota h cross y curly over curly z alpha over x minus alpha x minus iota h cross, sorry, minus iota h cross I have taken outside. So it is y curly over curly z, and both are operated with this psi x, so it can be written in this way. And this is minus iota h cross y curly over curly z alpha over x into psi x minus alpha over x and y curly over curly z and psi x. So say these two terms basically independent of z. So that means this whole of the term will become 0. Similarly, it is also depending upon x only, so that's why its differential is also, or the derivative or the partial derivative is equal to 0. So that means overall it is equal to 0. Thus, in nutshell, I can conclude that commutator of Lx with alpha over x is equal to 0. Similarly, I can prove that Ly alpha over y, its commutator is also equal to 0, or Lz and alpha over z, it's also equal to 0. So thus I can conclude that orbital angular momentum, it commute with potential energy of central force, right? So that's it. So thanks for watching this lecture. In the next lecture I will discuss one more problem.